Hey everyone, this is another one of those AP test questions. I've been hitting 2006 pretty heavy this year. I think they've got a lot of really good problems actually in this particular AP test. And the number 6 question, the investigative task for this particular year, I think is particularly good, and I think not terribly hard, but definitely you got to have your wits about you. So I'm going to read through it. I'm going to give my version of the answers. I think it would score a top score, but you guys can be the judge of that. All right. So Sunshine Farms wants to know whether there is a difference in consumer preference. Oh, wait, let me back up just a second. Never forget to look at the directions, because the directions oftentimes will give you some guidance, and we want to do that. So show all your work, we know that. Indicate clearly the methods you use, because you will be graded on the correctness of your methods as well as the accuracy and completeness of your results and explanations. All right, so getting back to it. Sunshine Farms wants to know whether there is a difference. I'm going to highlight words that I think are important in consumer preference for two new juice products, Citrus Fresh and Tropical Taste. In an initial blind taste test, 8 randomly selected consumers were given unmarked samples of the two juices. The product that each consumer tasted first was randomly decided by the flip of a coin. After tasting the two juices, each consumer was asked to choose which juice he or she preferred, and the results were recorded. All right, so we've got a few things here. We've got an N that's 8, so we've got a very small sample size. That's something to take note of. We do have some random selection. They're not randomly selecting the people, but they're randomly selecting which drink, so they're randomly selecting the treatment. That's totally okay. Difference is a key word that we want to kind of keep in our hip pocket for now. All right, so it says, let P represent the population proportion of consumers who prefer Citrus Fresh. In terms of P, state the hypothesis that Sunshine Farms is interested in testing. All right, well, they're going to want to test the null hypothesis that the population is equal to 0.5. Now, why that? Well, because if we're not given a proportion of the population, if we're not given a p-value to test against, we assume 50-50. So 50% would choose Citrus Fresh, 50% Tropical Taste. That's the rationale for this 0.5. The alternative would be that P does not equal 0.5. Now, why is it does not equal? Because of this keyword difference right there. They're not telling you that they think one or the other is going to be the winner. They just want to know, is there a difference between them? I don't really see that you need anything more than that in this. Now, when I copied this, I did look at some of the solutions to see what the spacing was for the questions, and I tried to mimic that as best I could in this handout. All right, so you don't need to fill the whole space. We might add, assume the two juices are equally liked. We could add that for sure. And they tell you that P is Citrus Fresh, so I don't think you need to restate that. All right, so moving on. The next question. Excuse me. One might consider using a one proportion z-test to test the hypothesis in Part A. Explain why this would not be a reasonable procedure for this sample. Well, z-tests, this is what I'd write, z-tests require an approximately normal sampling distribution. fact, I'm going to add sampling or population. We don't know either. It wasn't stated that the population of all people would prefer one or the other, or that it was normal. That's really what we're looking for. So we have to meet the large counts condition. If it's not given, we have to meet the large counts condition. So the large counts condition is going to be n, which in this case is 8, times p, the p that we assume in the null hypothesis. Sometimes that could be written as p sub naught, or in this case p sub citrus fresh, CF. That has to be greater than or equal to 10, and n times p has to be also greater than, or sorry, n times 1 minus p has to be also greater than or equal to 10. These values would be equal. Neither one is true, so the large counts condition has not been met. Therefore, we don't know if the data is approximately normal. That's the real problem there. All right. So, anytime we have proportions, we've got to have normal. Moving on, let x, there we go, let x represent the number of consumers in the sample who prefer citrus fresh. Assuming there is no difference in consumer preference, there's your 50-50 right there. Find the probability for each possible value of x. Record the x values and the corresponding probabilities in the tables below. All right, well, we have a binomial situation. They either prefer citrus fresh or they don't. We have a fixed number of trials, 8. We have a fixed probability, 0.5. And let's see, what am I missing? Oh, each person would be independent. So we need to make sure we list our conditions. It's binomial. Let's see, prefer or not. Citrus fresh or not. Let's see, we have, what else do we have? Each subject is independent. Do we know that for sure? Was it stated? No, it wasn't. So we have to assume one subject's choice does not affect another. All right, let's see, what else have we got? There is a fixed number of trials. That's our 8 subjects. And finally, each subject's choice has an equal probability each choice, how do I want to put that? Each choice has an equal probability of occurrence. So now we need to think about how many people could choose this product. Well, it's possible that none of them do. And so what I'm going to do is I'm going to look at the binomial PDF. Let's see. There we go. So I'm going to go second vars into the distribution. I'm going to go binom PDF. We have 8 trials. Looks like I've already got it in there. A p-value of 0.5 and an x-value of 0. And if I paste that, I get a value, and I'm going to go out about 5 decimals here, of 0.00391. And it's easy to go all the way down, so I've got 0 to 8 that I need to do this with. So it's easy to just copy that and change the last 0 to a 1. So 1 is going to be 0.03125. For 2, oops, copy and change, I've got 0.10938. These decimals aren't super long. You could use the whole thing. It would be fine if you did. For 3, it's going to be 0.21875. When I go to 4, I get 0.27344 if I'm rounding to the 5th decimal. For 5, something interesting happens. My value for 3 and 5 are the same. For 6, my value for 6 and 2 are the same. And guess what? The value for 7 is the same as 1. I don't think I need 2 decimal places there. There we go. And for 8, it is also 0.00391. And if you don't believe me, here I'll show you. Okay. So these are our binomial probabilities. This is discrete. You cannot have 1.5 person's opinion here. So these are discrete probabilities. We need to maybe keep that kind of in mind, or that thought. Okay. All right, so when testing the hypothesis in Part A, Sunshine Farms will conclude that there is a consumer preference if too many or too few individuals prefer citrus fresh. Based on your probabilities in Part C, is it possible for a significance level, the probability of rejecting the null hypothesis when it is true, for this test to be exactly 0.05? Justify your answer. Well, the answer to that's simple. The answer to that's no. These are the only probabilities that can occur, and 0.05 is not one of them. So for D, I'm going to say no. None of the probabilities are exactly, or none of the discrete probabilities given in Part C are exactly 5% or 0.05. It's actually super unlikely or maybe even impossible that any discrete probability situation would have a significance of exactly 0.05. So, but I think that would get you the answer right there. I like that word because it defines that we cannot have probabilities between these values. All right. And let's see, we're almost done. F. F gives a whole page to answer. Wait, where's F? Oh no, I'm sorry, I'm jumping ahead. I need E first, then F. All right. So the preference data for the 8 randomly selected consumers are given in the table below. 2 of them like the citrus fresh. So we only had 2 people that preferred that. Based on these preferences and your previous work, test the hypothesis in part A. Well, so the probability that exactly 2 like this product is about 11%. But keep in mind, this is a does not equal. It's a difference problem. And what you want to remember is that we have to double the probability. So the probability that exactly 2 subjects would prefer citrus fresh is 0.0, oops, I don't need a decimal there, or it's 0.10938. Because this test is two-tailed, and the reason for that is that the alternative is p does not equal 0.5. We would double the p-value. To about 0.219, or about 22%. Because the p-value is so large, we would fail to reject the null. How about we say larger than any reasonable alpha? We would reject the null, or sorry, we would fail to reject the null. That's to fail. And conclude there is not a significant difference in preference between the 2 juices. Alright, and unfortunately that bell means I'm out of time for F, but let me talk quickly about F and I will attach my answer to this the follow-up study on this, they're asking about a follow-up study, what should be done, and I will make this nice little highlight right here. Make one recommendation to make the study better. Well, what was the thing that we noticed about the study being a problem in the first place? It was that our sample size was too small. So we're going to make a statement that says that a larger sample size is needed so that we can meet the large counts condition. And when we meet the large counts condition and all other conditions, then we can generalize the statistical findings to the general population. I also added that sample size has to be greater than or equal to 20 to make that work. Sample size, larger sample size is almost always a good thing, but in this case that is the answer that we would be looking for. Anyway, I'll finish this up in my scanned copy of this. I hope this made some sense. I hope this maybe brought a couple of things into focus for you. It's really a cool problem because it encompasses so much of what we've learned this year. Anyway, thanks guys for your time. I appreciate it. We'll see you later.